This last talk on the breast is going to be about malignant breast cancer. If you're not talking about skin cancer, then just some epidemiology. Breast cancer is the most common female cancer. Okay, so breast cancer is the most common cancer in women. So most common cancer in women. And it's the second most common cause of cancer-related death in women. Behind lung. So it's very important that you know these well. Some background information, the risks are obviously going to be in females because they have more breast tissue. And older age, because older age predisposes you to more mutations in basically any cancer. You can have increased risk if you have increased estrogen exposure. Again, the breasts are very hormone sensitive, so increased estrogen exposure. These include things like obesity due to aromatase. These include things like early menarche, late menopause, which exposes you to more ovulatory cycles and estrogen. Other things is if you're black, this also not only increases your risk for breast cancer, but for a risk of triple negative cancers. I'll talk about what that is in a second. Or if you have genetic mutations. Those are just some risks. There are a lot more risks, but these are the major ones that you should know. Let's talk about these two in more detail. So, what is a triple negative cancer? I just said that breasts are sensitive to hormones. These hormones we talked about are things like estrogen and progesterone. Those are the estrogen, progesterone. Those are just regular female hormones. And breast tissue express receptors for these. So receptors. They can also express receptors for other things like growth factors. The main one being HER2 new. That is a growth factor. And if cancer cells express these, we can call these things like estrogen positive cancers or progesterone positive cancers or HER2 new positive cancers. So that would be a triple positive cancer. However, if they don't express these, that would be a triple negative cancer. Why is it important that they still express these? Well, if they express these, we can target them with drugs. So if they express estrogen, for example, we can target it with anti-estrogens like tamoxifen. We talked about that drug in a couple chapters ago. If they express receptors for HER2 new, it's going to be a little bit more aggressive because this is a growth factor. If you have more growth, you're going to have a more aggressive, more proliferative cancer. So it's going to be more aggressive. However, the silver lining is we have something that can target HER2 new directly. And that's going to be a monoclonal antibody against HER2 new called trastuzumab. So that's what they mean when they say triple positive cancers or triple negative cancers. So being black predisposes you to breast cancer, but also predisposes you to triple negative. And if they don't have any of these receptors, then we can't really target them. And so these cancers are more aggressive. I'll say more aggressive. That is for that topic. This next topic, genetic mutations. 90% of breast cancers are sporadic, but 10% come from genetic predisposition to it. So I say 10% is hereditary. Suspect this with a patient that has a lot of first-degree relatives that have cancer. Very important is first-degree relatives. Doesn't really matter if it's like a patient's paternal aunt or grandfather's sister or something like that. It has to be a first-degree relative. Or the patient might just have breast cancer really early. So if they come in and they're like 25 and they have breast cancer, or if they have multifocal bilateral breast cancer, you're thinking something's up. The most common cause of hereditary breast cancer is mutations in these genes called BRCA. BRCA1, BRCA2. BRCA is from a gene called breast cancer susceptibility gene. It's quite a giveaway of a name. The BR comes from the BR of breast, the CA comes from the CA of cancer, and those make up your BRCA genes. And BRCA is a tumor suppressor gene, and it also, I don't need to write this down, but just kind of a background knowledge, is a tumor suppressor gene, and it also fixes double-strand DNA breaks. And so that's how it controls cancer, its growth. So if you have a mutation in BRCA 1 and 2, you're predisposed to all types of cancer, mainly breast and ovarian. Now BRCA 1, that's right here, BRCA 1 has a higher risk of cancer than BRCA 2, so I'll say increased percentage of breast cancer, mainly invasive ductal carcinoma. That may not make much sense to you right now, but we'll talk about that in a second. So there's no invasive ductal, especially the medullary type. Also ovarian cancer. In particular, epithelial ovarian cancer. You remember talk about, serous and mucinous epithelial cancer is going to be your serous one. So how about BRCA 2? BRCA 2, you're going to have the same susceptibility to cancer. It's just a little lower. It's not like incredibly low. It's still like 40 to 20%. So it's just a little bit lower than BRCA 1. But the main thing you need to know is that it's shown to cause breast cancer in males. So if you have hereditary breast cancer in males, you see it through, through a question stem, then you're thinking of a BRCA 2 mutation in that patient. One more thing I want to go over. A little bit more anatomy than anything. Breast tissue is mostly found in the upper outer quadrant in females. So where you would associate breast cancer with more commonly being in the upper outer quadrant, those drain into your axillary lymph nodes. Your lymph nodes in your armpit. And we can use that fact to check for prognosis. We can biopsy the lymph node, and if it's spread to the lymph node, then we know it's somewhat of a worse prognosis. And we do that by what we call sentinel node biopsy. Way back when doctors would when they did a mastectomy, they would also take out all the lymph nodes in the axilla. And that wasn't good. It left really long-standing, really severe lymphedema. You'd have like a 50-pound arm, look like elephantitis. So someone came along and said, what if we just inject dye, and if there's lymph node spread, then the first lymph node, the closest one, the sentinel one, sentinel meaning it looks out for everything else, would pick it up, and then we would know it's spread. If it didn't pick it up, then we know it hasn't spread. So that way we can only we only need to biopsy one of them. We don't need to biopsy all of them. So that's what we do now. We call that sentinel node biopsy. And we do that for your axillary lymph nodes, but also know a little trick question. What if the cancer isn't in your upper outer quadrant? What if it's more inner medial? Then inner quadrant cancers will drain to your internal mammillary lymph nodes. Internal mammillary lymph nodes, if it's in your inner quadrant. Know that well? It's a very common trick question because we always just associate with axillary lymph nodes with breast cancer. And then last, know where it likes to metastasize to. And it really likes to mets to the lungs because it's close, and to the bones, especially your spine, again, because it's close. So lungs, bone, common met location. I think that's enough about the background of breast cancer. Let's talk about the actual types of breast cancer. If you recall, your breasts are made up of lobules, and they're made up of ducts. Your lobules produce the milk, your ducts drain them. So lobules, ducts. It shouldn't surprise you then that breast cancer will come from these, either in your lobules or cells from your ducts. So another important principle you should know beforehand, though, is that there's a progression of cancer usually. Usually get cancer in situ. Basically it's situated as not invasive, but that can ultimately progress to invasive cancer. So it's a bit of a spectrum. You start with just cancer growing, then if it starts to invade through your basement membrane, starts to spread, then you can turn into invasive cancer. So we'll start with lobules first. The lowest grade will be your lobular carcinoma in situ. Yeah, these are very difficult to palpate. All right, difficult to palpate. But are often multifocal and bilateral. One of the most important things you should know about LCIS is that cells here lose their E-cadherin. What the heck is E-cadherin? E-cadherin, or cadherins in general, are adhesive proteins. They help cells bind together. And when you lose that, they start to separate. And they form this kind of line of cells. That is very, very classic of LCIS. Now LCIS can progress and then it just becomes invasive lobular cancer. Invasive lobular cancer. But the most important thing you should know is probably this loss of E-cadherin. That does it for your lobules. Nice and quick and easy. Let's move on to your ducts. Let's start with your, I guess, the beginning of your spectrum. So in situ cancer, or ductal carcinoma in situ, comes from any sort of hyperplasia or proliferation of cells in your duct. And if you see that, then you're going to see the cancer basically clogging up your duct on histo. There's a nice picture in my notes. A subtype of this is called Comodo Carcinoma, where you have the duct being plugged, but in the center you have necrosis. Now I don't have a red marker, so I'll just make it purple, or not at all because this marker is out of ink, but just pretend there's a area of necrosis here. Okay, that's just a subtype. Again, another great picture in my notes. Make sure you see it. You can recognize it very easily. Pagets can be a subtype of DCIS, or can be a subtype of any cancer. This is when the cancer spreads to your skin, your epidermis. And when it spreads to your skin, it can cause it to be erythematous, can look like eczema, very red, scaly, peely, can look like a host of things. Just be sure you can recognize it well. So Pagets will have a red breast, and that just signifies that there's an underlying cancer. That's something you should know just on physical exam, on general observation of the breast, possible Pagets. So DCIS in situ can progress, of course, to invasive ductal carcinoma. So invasive ductal is your most common. Unfortunately, it also is the one of the worst prognosis. You're going to have breast tissue, but you're also going to have a lot of connective and fibrous tissue. Proliferation of that we call desmoplasia. Creates this very rock hard, firm mass, rock hard from that desmoplasia. And if you cut it, biopsy it, you'll see that fibrous tissue will have this kind of stellate appearance, star-like appearance. Again, another picture in my notes, make sure you check that out. Invasive ductal has many subtypes. We talked about one of the subtypes earlier. Hopefully you didn't forget, medullary subtype. That is associated with BRCA1. A very, I guess, a classical one that we've all learned in med school is going to be your inflammatory. An inflammatory invasive ductal carcinoma is when it invades into your lymphatics and it blocks it. And so you get poor drainage, and the skin on your breast starts to dimple. It can turn color, it can turn reddish, orangish. And that dimpling and that orangish color makes it look a little bit like an orange peel. And so I'm just gonna wing it. I'm gonna say it's called peau d'orange, or just peel of the orange. If you don't want to sound like me, an idiot, you can just call it a peel of the orange, and it looks like an orange peel. Those are your invasive malignant cancers. Hope you enjoyed the video. See you next time.